Hello and welcome to the Unit 1 Section 3 video on solving equations with variables on both sides. So we have talked about solving multi-step equations. That was our last section. But everything so far has involved having a variable on one side of the equation and we're trying to isolate that variable. Well, what do we do if we have a variable on both sides of the equation? Well, that is what we're going to cover in this section. And again, it's not anything radically brand new or particularly difficult. We're just adding one more piece to the puzzle of things that can happen when you're solving equations. Remember, this unit's all about solving equations. So each section we're giving you a new piece to consider when you do solve equations. So let's go over the overall steps for solving equations. And we kind of gave you a couple of those pieces in the last section. So first, you're going to remove all parentheses in your equation by using the distributive property. Okay. Once you use the distributive property, then you're going to simplify both sides of the equation. And you do that by combining like terms. Once you've combined like terms, you're going to get all the variables to the left side of the equation by using addition or subtraction. Then you're going to get all the constants to the right side of the equation. And you're going to do this by using addition and subtraction again. And if you think about it, think back to all those examples that we did in the last section. These are the steps you're already doing. We're just writing them all down in one place for you now. Then we will remove the coefficient. Remember, the coefficient is the number in front of the variable. We're going to remove the coefficient of the variable using multiplication or division. Okay, so one thing I want to note here is in 3 and 4, we tell you to get the variables to the left and the constants to the right. There are cases where you can flip that, okay? The main point is you just want to get the variables to one side of the equation and get the constants to the other side. You just want to get those separated out on either side of the equal sign. But if you are very procedural and you need to have a direction of getting the variables on the same side every time, go for the left for the variables. Put the constants to the right. But again, it doesn't really matter which side they're on, okay? So to help you remember these steps, we have this mnemonic device. Don't call me after midnight, where the first letter of each of these words stands for a step in solving equations. So the D in don't stands for distribute. That's the first thing you're going to do is distribute. Then the C stands for combine like terms. The M in me stands for move the variable. Move the variable to one side or the other. The A for after stands for add or subtract. And then finally, the M stands for multiply or divide. So this may help you remember the order in which you need to do things. So we're going to, the rest of this video, just go through more examples so that you have a good selection of examples to refer to when you're solving your own problems. So we'll start here with the first two on the bottom of the page. Okay, starting with this first example, what we want to do is we've got nothing to distribute, we've got nothing to combine on either side. So we move on to moving the variable. We're going to get the variable on one side, stuff without the variable on the other. So let's do that by adding 2x to each side. And when we do that, we're going to get 7 minus x on this side and 5 on this side. Then we're going to subtract our 7 from each side. And that leaves us with negative x equals negative 2. But we haven't got x by itself yet, so we need to either multiply or divide by negative 1. So let's divide by negative 1 on each side. That gives us x equals 2. All right, for the next one, we are going to subtract r from each side to get r on the left-hand side. So that's going to give us 15 minus 2r equals 1. And then we're going to subtract 15 from each side. And when we do that, we get negative 2r equals negative 14. And then we are going to divide each side by negative 2. And so r equals 7. All right. Moving on to number 3. Let's subtract 4r from each side, because there's nothing to distribute and there's nothing to combine. So this is very similar to the ones we've done. And that's going to give us 1 plus r equals negative 5. Now let's subtract 1 from each side. And that's going to give us r equals negative 6. And we're done. That's it for that one. For the next one, let's subtract 4x from each side. That's going to give us negative 3 plus 2x equals 3. Then we're going to add 3 to each side. We get 2x equals 6. And divide by 2. So x equals 3. For number 5, we have a 6x on this side. So in the spirit of getting it to the left-hand side, we're going to subtract 6x from each side. And when we do, we get negative 9x equals, or plus 5, because that's still there, equals 5. Now we're going to subtract 5 from each side. That's going to give us negative 9x equals 0. Divide each side by negative 9, and you find that x equals 0. For number 6, we have negative 5. So let's see, let's add n to each side. Nothing to combine, nothing to distribute. So we're just moving things from one side to the other. So negative 6 minus a negative n, 6n minus an n gives us a 5n equals negative 12. Oh, I'm sorry. I should have been adding there. See, this is why you use a pencil, because mistakes happen and we need to be able to erase mistakes so we can correct them as we go along. So this should be 7n, because we added n to each side. So 6n plus n gives us 7n. All right, add 5 to each side. And we have 7n equals, so negative 12 plus 5 is going to give us negative 7. And we divide each side by 7 to give us n equals negative 1. Okay, so for the next one, now we have like terms that we need to combine. Okay, so let's do the combining of like terms first. Negative 4v plus 8v on the left-hand side is going to give us 4v. 5v minus 6v is going to give us a negative v plus 15. Now we're going to move this v to the other side by adding it. So that gives us 5v equals 15. And we divide by 5 on each side, so v equals 3. For number 8, we have two k terms on the left side. So we're going to combine those k terms. 4k minus a k gives us a 3k. And then over on the other side, there's nothing to combine, so we'll just write it down. Now we move things. Now this one I'm going to show you where it doesn't really matter what side you put the variable on. And sometimes it's easier because it keeps you from having to deal with negatives. So I'm going to subtract 3k from each side here. That leaves us with 10 on this side. And that leaves us with 8 plus 2k, because 5k minus 3k gives you 2k. Then I'm going to subtract 8 from each side. And that's going to give us 2 equals 2k. And I think you can very quickly see that k is going to be 1 when we divide each side by 2. Now, I don't have k equals 1, I have 1 equals k, but remember, those are both the same thing. All right, nothing to combine on the left-hand side, but we do have some x's to combine on the right-hand side. Negative 4 minus another 3 gives us a negative 7x. And now we can start moving things. So I'm going to add 7x to each side here, because I always find it a little bit easier, at least personally, to get things that are positive where I can. So 7x minus 4x gives us 3x. Don't forget the 2. That's still out in front. And then we're left with negative 16 on the other side. Now I'm going to subtract 2 from each side. And that's going to give us 3x equals negative 18. Divide each side by 3. And we have x equals negative 6. For number 10, we've got two p terms. So negative 7p plus 5p is going to give us negative 2p. And then we have two p terms on the other side. So we have negative 8p and a 4p, so that's going to give us negative 4p. Let's add 4p to each side. That's going to give us 1 plus 2p equals 3. Subtract 1. That's going to give us 2p equals 2. And when we divide by 2, we get p equals 1. All right, last two examples on this page. We've got a 2 and an 8. So the 2 plus 8 is going to give us 10. And then we have a negative 6n and a negative n. So that together is going to give us negative 7n. And then we have n minus 6 on the other side. So let's add 7n to each side. And that's going to give us 8n minus 6 on the right-hand side. And then we'll add 6. And that's going to give us 16 equals 8n. And then dividing by 8, we end up with 2 equals n. And for number 12, we have 1 minus 2b on this side. 8b plus 3b is going to give us 11b. Now we are going to add, or I should say yes, add 2b to each side. That gives us 1 equals 1 plus 13b. and then we subtract a 1 from each side. That gives us 0 equals 13b. Divide each side by 13, and you get 0 equals b. All right, let's go on to the next page and do a few more examples. So now, on this page, we have some distributing to do. Okay, the front page we did all this combining of like terms. Now we're going to put distribution into the mix. So for number 13, nothing to do with the left-hand side yet, so we'll go ahead and write that down. Let's distribute here. 8 times 8 is 64, and 8 times negative 8 is negative 64. And then from here, we can just subtract 8x from each side. We get negative 8 equals 64 minus 8. That's going to give us 56x here, minus 64. And then we're going to add 64 to each side. And that's going to give us 56 on this side. And when we divide each side by 56, we get x equals 1. For number 14, nothing to do with the left-hand side again, but we need to distribute the right-hand side. So negative 5m plus 40. The negative 5 times m and the negative 5 times negative 8, that gives you the positive 40. And now we're going to add 5m to each side. So add 5m. So that's going to give us 12m plus, just 12. 12 plus 7m equals 40. Then we're going to subtract 12 from each side. That gives us 7m equals 28. Divide each side by 7, and you're going to get m equals 4. Number 15. In fact, I'll leave those up for you while we do the next two. Again, nothing to do with the left-hand side. All the distributing's on the right-hand side. So when you see a negative sign out in front, we have to distribute this negative sign to each term. So negative 1 times x gives us negative x. Negative 1 times 8 gives us negative 8. And now we are going to add 4x to each side. Could I have just as easily added x to each side? Yes. Just as long as you're getting the variable on one side and the stuff that does not have variables in it on the other. That's perfectly fine. It will come out the same. So you got 1 equals 3x minus 8. Now we're going to add 8 to each side. That gives us 9 equals 3x. Divide each side by 3, and we get x equals 3, or 3 equals x. All right, for 16, the distribution's on the left-hand side, so 3 times 1 is 3. 3 times 5 is 15, so that's 15n. And now we're just moving things from one side to the other. Subtract 7n on each side, and you're going to get 3 plus, so let's see, 15 minus 7, I believe is going to give us 8. And then subtract 3 from each side. And that's going to give us 8n equals 16. Divide by 8, and n equals 2. All right, 17 and 18. So we have nothing to combine and nothing to distribute on the left-hand side. The negative 2p is kind of on its own, but we do have to distribute this. So we've got negative 30p, and then negative 6 times 7 is going to give us negative 42. Now let's combine like terms, because we have combined terms that are the same on the right-hand side. So negative 2p minus another 30p gives us negative 32p minus 42. And now we're going to move things. So let's add 32p to each side. And when we do, we get 20 plus 31p equals negative 42. And then we add 42 to each side. And we're going to get, oh, I'm sorry, other way around. We're going to subtract 20 from each side. Again, I've been doing this for years, and I make mistakes. So you know you're going to make mistakes. So use a pencil when you do this. Negative 62 on this side. Then we divide each side by 31, and p is going to be negative 2. All right, so you kind of see the number of steps that we're having to do is starting to increase a little bit when we have to do more with the equation. Let's look at number 18. 1 is by itself. We got to distribute the negative 8. So we get negative 8r minus 32. The other side remains the same. Combine our like terms, that being negative 32 and 1. So that's going to give us negative 31. Now let's add 8r to each side. That gives us negative 31 equals r minus 25. And then we're going to add 25 to each side. And when you do that, you're going to get negative 6 equals r. All right, moving on to number 19. We're going to distribute this negative sign. So we have negative 3x plus 4. Negative 3x plus 4 equals 6. 2 times negative 1 gives you negative 2. 2 times 4 gives you 8. Now we combine like terms. So 6 minus 2 gives us 4. And now I'm going to add 3x to each side. That gives us 4 equals 4 plus 11x. Subtract 4 from each side. And I believe you can kind of see where this is going. Get 0 equals 11x. Divide by 11, x is 0. And 0 can be a solution. You've seen that a few times. 0 can be a solution. You put 0 back into this, and you are going to get two things that equal each other. That's another good point I want to bring up. You can always check your work by putting your answer back into the original equation and see if you get two numbers that equal each other. All right, just a few more examples here. We've got 2x here. We're going to distribute. 3 times 6 gives us 18. 3 times negative 3 gives us negative 9x. Then we have 6. Distribute this negative, so we got negative 5x. Negative times a negative gives us a positive 2. Combine our like terms. So we're going to have 18 minus 7x on this side. On this side, we're going to have 8 minus 5x. Let's add 7x to each side. And that's going to give us 18 equals 8 plus 2x. Subtract 8 from each side. You're going to get 10 equals 2x. And then finally divide each side by 2, and you get 5 equals x. All right, two last examples to cap off this section. 3 times 1 is 3. 3 times negative 5 gives us negative 15r. 2's by itself. Negative 8 times 3 gives us negative 24r. And then negative 8 times negative 8 gives us positive 64. We've got some like terms to combine on the right-hand side. 64 and 2 together make 66. Now we're going to add 24r to each side. So that's going to give us 3 plus 9r equals 66. Subtract 3 from each side. You get 9r equals 63. Divide each side by 9, and you're going to get r equals 9 will go into 63 7 times. And then finally, negative 8 times a gives us negative 8a. Negative 8 times 4 gives us negative 32. Then we have plus 6. Negative 5 times a gives us negative 5a. Negative 5 times 1 gives us negative 5. Let's combine our negative 32 and our positive 6. When we do that, we are going to end up with negative 26. The other side remains the same. Now let's add 8a to each side. And that's going to give us negative 26 equals 3a minus 5. Add 5 to each side. And that's going to give us negative 21 equals 3a. Divide each side by 3. And you're going to find that a equals negative 7. All right, I know this section was a lot of examples, but hopefully after seeing all these examples, you have a good understanding of how to approach these problems, how to work these problems, okay? A lot of math, when you're learning how to do new things, especially things that are procedural like this, getting the reps in, doing the repetition is going to make you good at this, okay? You got to get the practice. It's like being on a football team. A football team does not go out and play another team without ever practicing with each other. They practice their plays, they know what their field movements are going to be, and then they get out there and play the other team. That's how math is. You have to know how to approach these problems, and the only way you're going to get good at approaching different types of problems where you have distribution and combining like terms and having to move things from one side to the other is you have to practice it. That's the best way to get good at it. All right, that does it for this section. Our next section is going to be on special solution sets. So now that we are finding solutions to these equations, we're going to talk a little bit about what happens when you get into a weird situation, such as the variable disappearing when you're moving things from one side to the other. So that's coming up in the next section.